In this video, I'm going to talk about the diagram in the upper right-hand corner of page 6 of the Earth Science Reference Table. That's the relationship of transported particle size to water velocity. The first thing we should do when we're looking at any new diagram is, of course, look at the title, which we just talked about, and then you want to check out the axes. Along the bottom x-axis, we have stream velocity in centimeters per second. The y-axis, the primary y-axis, we have particle diameter in centimeters. And then on the right side, the secondary y-axis, we have different particle sizes. Right, so we go from boulders to cobbles to pebbles, sand, silt, and the very smallest particles are known as clay. Boulders are any particles that are larger than 25.6 centimeters in diameter. Cobbles are in between 6.4 centimeters in diameter and 25.6 centimeters in diameter, so on and so forth. As we can see, as we go down on this diagram, down on the y-axis, the particles get smaller and smaller. The other important thing to point out on this diagram is the location of this black line. This black line shows us the relationship between particle size and stream velocity. As stream velocity increases, we move towards the right in this diagram. Transported particle size also increases. Something you may have noticed that's a little bit strange about this diagram is if we look at the axes, it seems that the scale is inconsistent. Between 1 and 10, the interval is 1. Between 10 and 100, the interval is 10. Between 100 and 1,000, the interval is 100. This is known as a logarithmic scale. So just realize that the scale is dictated by whatever value is on the left-hand side for the x-axis or at the kind of bottom of the y-axis boxes. So from 1 to 10, it's going up by 1, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Then from 10 to 100, it goes up by 10 centimeters. As usual, we'll take a look at some practice problems. So feel free to pause the video and try them for yourself. Click play when you're ready to see the solution. So question 1, it's asking in what order will sediments be deposited? Key information is the fact that we know that the river is slowing from 100 centimeters per second down to 0.1 centimeters per second. How do we use this information? Well, we go over, we know a stream velocity, so we know a value on the x-axis, and our initial velocity was 100 centimeters per second. So we go up until it intersects this curve. That tells us that we're moving at 100 centimeters per second pebbles, as well as sand, silt, and clay. So we're moving all of these sediment sizes at the initial velocity of the river. But we also know that the river slows down significantly to 0.1 centimeters per second. So we start here, but then we slow the river down till we get to 0.1 centimeters per second. We draw a line over to figure out what sediments are still being carried. We are still carrying silt and clay. So to answer the first question, what sediments were deposited, since water deposits the largest sediments first as it slows down, pebbles are deposited first, all of the sand is deposited, and then a bit of silt-sized particles is deposited. So in what order are the sediments deposited? Pebbles, sand, and silt. Question 2 is asking about what is still moving, so what's still in transport. And the key term here is size sediments. And so we take a look at our chart, and we can see that at the slower speed, at 0.1 centimeters per second, the river is still moving silt and clay. Our last practice problem. It's always a good idea to identify what is the question asking and what information is provided to you. So we're looking for a stream velocity. So our answer will come somewhere on the x-axis, because that is the stream velocity axis. And we know that we're dealing with a 10 centimeter diameter particle. So how do we use the diagram to help us answer this? First thing we need to do is find 10 centimeters in diameter. It's going to be on the y-axis. So here's 10 centimeters diameter. So this is our starting point. We move over until we intersect the transit curve. And then we want the stream velocity, so we go straight down. That's the yellow line here. And then we read off the value on the x-axis. Remember, this is a logarithmic scale, and this box is started at 100, so it goes 100, 200, 300, 400, 500, so on and so forth. Our value is around 200 centimeters per second. I hope you enjoyed the video. If you have any suggestions or comments, please leave them below.